In this problem, we are told that a rocket launches into the air and that at the end of the powered portion of the flight, the rocket is 89.6 feet high and it lands 16 seconds later. We are asked to figure out what the speed of the rocket is after the powered portion of the flight and what is the maximum altitude reached. The first thing we need to do, or I want to do, is establish a coordinate system. And to establish a coordinate system, I'm going to say that anything that's going up in terms of direction, position, velocity, acceleration is going to be positive. So up is positive. Anything that's pointing down will be negative. Next, I want to go through, write, and draw all my known information. So if this is my ground, I have my rocket, which is launched to a specific point, and this point is going to be where the powered portion of the flight ends. And we are told that the powered portion of the flight ends at 89.6 feet. So this entire leg is powered portion. We don't know anything about that. We just know after that ends how high we are. After that ends, the engine shuts off. So then our rocket continues to go up and then it falls and it comes all the way back down to the ground. And at this point, right here, we don't know, but we're going to say the initial velocity is going to be some question mark. That's what we need to find out. The final velocity down here, we don't know what this is either. So the final velocity is going to be some question mark. But we do know the final position. If this is going to be 89.6 feet, we know that our final position is when we hit the ground, and our final position is going to be 0 feet. We also know how long it takes to hit the ground. T is going to be 16 seconds, and 16 seconds is from when the power turns off until when it hits the ground. The other piece of information we know is about gravity. We know that gravity always points downward, and because we said up is our positive position, gravity, which is an acceleration, is going to be equal to minus 32.2 feet per second squared because we're using English units. So now we have most of our information, and what is key is to realize that after this powered portion of the flight and we come up and we fall back down, gravity is the only acceleration that is acting on us, and it's a constant acceleration. A constant acceleration allows us to use our kinematic equations. So if we write these out, we can say the first one is the final velocity is equal to the initial velocity plus my acceleration times time. The second one is my final position is equal to my initial position plus my initial velocity times time plus 1/2 times my acceleration times time squared. And third, my final velocity squared is equal to my initial velocity squared plus 2a times my final position minus my initial position. So the change in my position. What am I looking for? That's what we need to ask. I am looking to figure out first the speed of the rocket after the power portion of the flight. The speed is going to be some velocity. I'm actually going to be looking for this initial velocity because this power portion of the flight is sort of happens before the problem starts, and we start when we're at 89.6 feet. So what I want to do is I want to look at the second equation right here. With this second equation, I know a lot of these pieces of information. I know my final position is going to be 0. I know my initial position is going to be 89.6 feet. I don't know what the initial velocity is. That's what I'm going to solve for. I know the time to go from here to here is going to be 16 seconds. And then plus 1/2 times gravity, which is minus 32.2, times this 16 squared. And now I can solve for this initial velocity. To solve for this initial velocity, let's get what this term right here is. So that term is going to be 0.5 times minus 32.2 times 16 squared. And that's minus 4,121.6. Minus 4,121.6. And now I can solve for my initial velocity. So I can add 89.6. I can move it to the other side of the equation. And I can divide by 16. So that gives me an initial velocity of 252 feet per second. Okay, so now that I know what the initial velocity is, when I stop this final portion of the flight, I can now do something different. For the second part, which is asked to figure out the maximum altitude, instead of applying these equations from where the engine stopped until where I hit the ground, I can apply the equation from where the engine stopped to the top of this trajectory, or as high as it goes. And this height will be some height h that we are going to figure out. So the other thing we know is at the very top, our velocity, our final velocity, will be equal to 0. So as we move, we have some velocity right here, which is equal, well, we know what this is now. Our initial velocity is equal to 252. And our velocity is going to continue to get smaller and smaller because gravity is slowing it down until we reach the very top where we're not moving upwards anymore and our velocity is 0. So if we apply the equation of motion between here and here, we will get, what do we need to solve for? We need to get in height. So we need to again use, what do we need to do? We can use this second position. Okay, what we need to do is we need to use this first equation to get how long it takes to get to the top of this trajectory. After we figure out how long it takes to get to the top of the trajectory, we can use this second equation to figure out what our final height is. So let's do that. First, let's apply equation 1. When we apply equation 1, we get our final velocity is 0 is equal to our initial velocity, which is 252, plus this minus 32.2 times time. This will get us 252, move it to the other side of the equation, divided by minus 32.2, and it takes 7.8 seconds to get to the top. So t is equal to 7.8 seconds. Okay, now by using equation 2, we're figuring out what this final height is. So our final position is equal to our initial position, which is 89.6, plus our initial velocity, which is 252, times time, which is 7.8, plus 1/2 minus 32.2 times 7.8 squared. And when we crunch these numbers, we'll have 89.6 plus 252 times 7.8 plus 0.5 times minus 32.2 times 7.8 squared. And this gives us a final height of 1,075.7 feet. So our final height is 1,075.7 feet. So now you know how to work a problem that's motion in one direction when gravity is the acceleration that is acting on the particle. And since gravity is constant, we are allowed to use our kinematic equations of motion.